It's going in large.
11, 12. Okay, thanks. Thank you. Okay, thanks. Okay, we're going to continue with our packets. We haven't talked about building product rule, chain rule, and quotient rule using graphs. So let's talk about that. So page 15. Give me 1 second.
What? Okay. It's like, okay. When I'm also gonna, during lunch, I'm gonna do like the intro of the video. I need to wear a person jacket, but that's like, I'm doing it now. I'm gonna write on it like, it's worse by MHS. No. Sign my name. You're able to cut to like. Yeah.
Okay, so page 15. We're going to be building our rules, whether it's product or quotient rule, depending on what information is provided for us. So here, part A says find P prime of 1. Before we can find P prime of 1, let's first focus on finding P prime of X. So this it's always going to be a two-step process. We can't find the derivative and the slope at the same time. So always focus on building your function first before you plug in your value. So for part A, we're just going to focus on finding P prime, but let's look at what P of X is defined as. So P of X is defined as f of X times G of X. So let's write that formula down, or that equation down. So if I want to find P prime, what do we have to involve here? Product rule, yeah. So we can't just say f prime times G prime. These are being multiplied. We have to go through product rule. So we'll build product rule in function notation. So in that, we know that's f prime times G plus f G prime. Okay, good so far? Right, now that we have our P prime, let's replace all the x's with ones. So P prime of 1 is f prime of 1, G of 1. So we have the G function and the F function provided for us. So the F is the one that's above and G is the one that's below. Let's talk about the easy parts here. How would you find F of 1 and G of 1? Just look for the what? The y, yep, just the y values, right? F of 1 and G of 1. So that's pretty straightforward. What do you think F prime of 1 and G prime of 1 will be looking for? What's another word for derivative? Slope. Yeah. And now, well, these are not curve functions. These are nice linear graphs. So we can definitely find the slope for these graphs just by doing rise over run, right? We know that we're not, if it was a curve like this one, really the only thing that we know is at the point where the slope is 0. But you know, you wouldn't be asked to figure out the slope of a curve function because that would, you know, the best you can do is estimation. But here, these are nice diagonal lines. We can definitely find the slope at those points. Okay, so let's do P prime 1 is equal to, we're starting off with F prime of 1. So let me highlight F of 1 here. Let me highlight G of 1. So just pick another point that's easy to find and do rise over run. What's the slope going to be for this line segment? Up 1 over 1, right? So slope is just 1. The slope of that line segment is 1. Back, now we're looking at G. We're looking for the order pair, Y value. What's G of 1 going to be? 4. Yep. Okay. F of 1, back to the Y value. Now for F, 6. Okay. What's the slope of this line segment here?
-1 over 2.
Good. Down 1 over 2, right? Down 1 over 2, -1/2. Now combine all your numbers, and that what your P prime will be. 1 times 4 is 4. 6 times -1/2 is -3. 4 minus 3 is, there's our P prime of 1. So once you have your derivative built out, you're just looking for either the slope or the order pair or the Y value. All right, next up, Q of X. Q of X is defined as F over G. So if I want to find Q prime, what do we have to involve here? Quotient rule. Okay. Running out of space, I'm going to use a little bit of space from below. Okay, so now we can replace every X with 4. Okay. Yeah, our definitions are provided for us at the beginning.
Oh, I didn't see that.
Okay, so now we're looking for the slope in the order pair, but now it's at X equals 4. So I'm going to highlight those points. All right, F prime of 4. What's the slope of the F graph at 4? -1. Okay. G of 4, Y value, 3, minus F of 4, 7. G prime of 4. What's the slope of this line segment? Good, 0. Okay. All over G of 4 squared. So 7 times 0 is 0. I get -3 over 9, which is -1/3. Just want to point out, what if we were at a place where there's a sharp corner? What would the slope be at these points or any of these corners here? Not 0. Good, undefined. So 0 would be a flat surface, either a flat line or the top or bottom of a smooth curve. But any corners, any sharp turns, they're all going to be slope undefined. Right. And there's a slope undefined show up. If it shows up anywhere, it's going to wipe everything out. The whole thing is undefined. So if one part is undefined, the whole thing is going to fall apart and be undefined. Okay, do you guys want to try 82 on your own? Again, P of X is defined as F of X times G, and Q of X is defined as F of X divided by G. So very similar process, just different graphs and different points. See if it all makes sense for us. Your P prime and your Q prime will look exactly the same since we're building off the same same definition. Yes.
Is here supposed to be 5? Oh, never mind, this times 0. I was adding 4 plus 1.
Oh, okay. All right, any questions with product rule, quotient rule? Yeah, I feel like, on the test, students don't have too much trouble with this. I think the only issue I see is students don't recognize, when they don't recognize product quotient rule, they'll do F prime times G prime, or they'll do F prime divided by G prime, and that throws off their answer. But I think most students recognize, okay, this is product rule, go through product rule, quotient rule, go through quotient rule. Okay, let's go to page 16. What is a bit more troublesome is chain rule. So building out chain rule in function notation kind of gives students a little bit more trouble. So let's walk through this, see how you guys feel. So page 16. Again, we're basing our formulas off the definitions provided for us at the top here. H is defined as f of x of g of x. So notice that this is not f of x times g of x. When you only see one x and you see f and g, that means it's a composite function. It's going to be a function within a function. This is going to be involving chain rule. Okay. So sometimes chain rule and product rule look similar, but the way you can tell the difference is you count the x's, right? If you have two x's, they're two completely separate functions. That's product rule. But if you only see one x, that means a function within another function. That's going to be chain rule. So h is defined as f of g of x, and s is defined as g of f of x. Okay, so let's look at h first. Since part A is asking about h prime of 1, let's write out h of x. So first, we need to recognize that there's a need for chain rule. And then the second is we want to apply chain rule accordingly. So H prime is equal to, so we know chain rule is outsized derivative times insized derivative. So what represents outsized derivative? How would we write that in function notation?
F parentheses.
F prime, right? F prime, parentheses, g of x. So that indicates we took the outside derivative because outside is f, outside derivative, but then we're keeping the inside function unchanged, right? So that's the outside derivative times what? Times g prime, yep. Because in this case, g is the inside function, so g prime is the derivative of that inside function. Okay, so far? Okay, go ahead and replace every x with 1. Are we okay so far? So this is where some students get into trouble. So I see a lot of students, they recognize chain rule. That's great. They filled out the derivative, but then from here, I see some students having trouble making the correct substitution. So the first thing I want you to recognize is that don't try to do this too fast. Okay, you're not going to do all this in one step. So figure out the parts that you do know, and then you're going to build it out, and eventually it'll become clear. So what is easy to find is not, we can't find f prime and g of 1 all in one step. But what we can find is we can find g of 1, right? And we can find g prime of 1. So those are manageable, right? So let's find that first, and then we can put that value in, and then we can go back and look at what is else needed. So let's look at g of 1. So g of 1, g is the, again, the graph on the bottom here. What's g of 1 equal to? 4. Okay, so you're going to rewrite the entire problem, but just replace g of 1 with 4. Okay, I know I underlined g prime of 1, but let's just do one thing at a time. Let's just find g of 1. So f prime of, I'm replacing the entire g of 1 with 4. Okay, so now this should feel a lot more manageable because, okay, the only thing that's left is f prime of 4 and g prime of 1. Okay, so that's manageable, right? We just have to find the slope of the f graph at 4 and the slope of the g graph at 1, and then multiply them together. So what's the slope of the of the f graph at 4? -1. Okay, so replace f prime of 4 with -1. G prime of 1.
-1/2.
-1/2. Yeah. And that's it. H prime of 1 is just -1 times -1/2. We just get positive 1/2. Okay, so for part B, let me build out the derivative with you and then see if you can finish the rest on your own. So S of x is defined as g of f of x. And hopefully we see that there's a need for chain rule. Let's find the derivative. Outside first. What's outside's derivative? G prime of. Don't change, right? We don't change that inside. We're not ready for that yet. Okay, so now we're done with the outside. We're ready for the inside. Inside is f prime. So now we're going to replace every x with what? 5. Okay, so try that. See if you're able to work it step by step. Don't try to do too much at once. Do the parts that's manageable, and then make the substitution, and then build out the rest of your answer. Okay, are we good so far? G prime of 6. What do you notice about G prime of 6?
Show me.
Corner. That means fine. So it doesn't matter what F prime of 5 is, it's going to be undefined. But for practice purposes, let's just put find F prime of 5. What's F prime of 5 going to be? -1. Yeah, I know it doesn't matter just for practice, but we know that ultimately it's just going to be undefined. Let's go to the next page and let's see if we can identify what if we mixed up product, quotient, and chain just for practice purposes. Yeah, so there's a bit more chain rule and product quotient rule to explore. So let's go to page 17. Okay, all the data that you need is at the very top. F of x is defined as g of x times h of x. What rule would you use? Product, right? Go ahead and build out your derivative using product rule, and then replace every x with 5, and then see if you can get down to your answer. Okay. Part B, what do you see? This is where the trouble spot is for students. Some students will put 3 and then they wouldn't continue with this problem and they will throw them off. So just if you can make that substitution, h of 5 is 3, then the rest of the problem should feel more straightforward. You're just finding g prime of 3 and h prime of 5.
But it's not possible, right?
Yeah.
Well, we don't have enough data for G prime of 3, so that'll be part of our answer. Whatever G prime of 3 is. We just can't go any further because we don't have enough data.
This still have from 5, right?
Oh, sorry, 5. Thanks. That's my bad. All right, part C. What do we use? Close triangle. Any questions with part C? Okay, part D is a little bit different here. Can you spot what's needed here? Chain rule. But what's strange about this is that there's a mixture of function notation and actually algebraic power rule. So we have to just know that, that there's a mixture of different types of notation, different process here. So this function notation, we'll leave it in function notation, but if something can be done algebraically, we're going to go through our derivative rule. So we said chain rule, which means we need to identify outside and inside and take turns with each. What's outside? What's the outside portion? Right, yeah, parentheses or bracket cubed. Inside is G. So the outside will do power rule, but the inside, the best we can do is leave it in function notation. Yes.
Isn't
G of,
I looked at you.
I see, yeah, G of 5. Okay, okay, what's outside's derivative? What fills in here?
G of X.
Oops, sorry. Replace every X with 5. Okay. Okay, let's fill that piece out, G of 5. Go ahead and put G prime of 5 as well. Sorry, G. Let me do a, sorry, any questions with part D here? Let me flip it around where there's also a mixture, but let's say, no, sorry, jumping ahead here. Let's say f of x is defined as g of 2x minus 1. Can you copy that down? Call that part E. If I want to find this derivative, notice that there is a mixture of function and notation and expression. This is also what? Also chain rule. Okay, so can we identify the outside and inside for this one? What's the outside? It's just the G parentheses, right? Or yeah, just the G parentheses. Right? That's the outside. What's the inside? So we'll take turns with the derivative. G becomes what? G prime. What goes inside the parentheses? Is minus 1. Times
2.
2. And then we'll replace all the x's with 5. We may not have a value to plug in, but we'll leave it alone. So sometimes you may have chain rule where there's an outside and inside component, but there may be a mixture. Sometimes the outside could be function notation, which the best you can do is leave it in function notation. But sometimes the outside or inside can be an expression, which you can apply a real derivative rule for it, just depending on where it is. Okay, page 18. We talked about this briefly yesterday, how if we want to find a horizontal and vertical tangent, they're going to come from the derivative. So we're going to find dy dx. And then if you want to find horizontal tangent, you're going to set the numerator of the derivative equal to 0. If you want to find the vertical tangent, you'll set the denominator of the derivative equal to 0. But either way, we have to find the derivative first. So look at 57. If we want to find the derivative, what process is needed? Yeah, all power rule, but what else? Implicit, yeah. You see y's mixed into the equation, so you know you got to keep track of your dy dx's. How many dy dx's will show up? 2. Okay, go ahead, try that. See if you can find your derivative, dy dx. And then once you have your dy dx figured out, your derivative figured out, then you can focus on finding your horizontal tangents and your vertical tangents by looking at either the numerator or the denominator. Okay, we're not quite done yet, but any questions up to this point? So power rule for all the terms, collect your dy dx terms on the left side, factor your dy dx out, divide over, and then horizontal tangent, you're going to focus on the numerator. And I got x equals -4. Now, horizontal tangents, they're all going to have to look like y equals a number. So right now we have the location of the horizontal tangent, but it's still not good. It's not quite a line equation yet. So I have the x value. How can I find the y value?
Plug it into the original.
Yep, into the original. So anytime we're looking for location, look for the original, go to the original. Now, when you solve for y, not only are you finding your y value, you're also going to be creating the tangent line equation, which is going to be a y equals a number. So that y equals is indicating the y value, but it's also indicating the equation of that line. Okay, in this unit, you'll get to use your calculator. I know it's a lot to do by hand. Yes, you will.
For this one?
Calculator for the test.
Is it 2 seconds like half time?
No, you can use your calculator anytime. But there are problems I'm going to ask you to show your work, so you can potentially use your calculator to double check, but I still need to see your work. So not only do we find the y value, we're also creating these linear equations, these horizontal lines, y equals 0 and y equals 10. Those are the horizontal tangents that we're looking. Okay, where do we look for vertical tangents? Denominator. So set the denominator equal to 0. Now notice that you're going to solve for y, but y is not good enough because vertical tangent are vertical lines, so they have to be x equals a number. So we're going to have to look for our x values since we're asking for vertical lines.
But they don't want us to find slope. Yes.
Sorry.
They don't want us to find slope. Right?
Well, if it's a vertical tangent line has slope undefined, and your equation will look like just x equals a number. Yeah. And your horizontal tangent line will be y equals a number. So here we have two horizontal tangent lines and two vertical tangent lines. But sometimes when you set your numerator or denominator equal to 0, you may not be at the variable that you want. So you may have to plug it back into the equation to get the variable that you need for your lines. Okay, so let me see. Homework will just be pages 16 through 18. We've done a lot of those problems, so
Take a nap. You feel me? You can go. I don't know. I'll go do this. Hey.
guys, I want to do one more thing here before we wrap up. 16. So I'm about probably 3/4 of the way finished with grading your quizzes. I'll have them back to you on Monday. So what I've seen so far, the first page, that number 1 power rule, I think for the most part, pretty good. I think the only big issue that I see is when the problem looks like this, some students would forget to not only convert, but then get that exponent to be negative. So in this case, it's 2 things, right? You got to get that radical to a rational, and then that rational needs to be up in the numerator. So that's a minor mistake that I saw. Number 2, quotient rule. Most students understood the need for quotient rule. I think the issue there was distributing the negative through, and that threw off some of your signs, but that's a pretty minor mistake. The back page, for the most part, looked pretty good. I think students were getting mixed up with increasing speed versus decreasing velocity, and either getting them mixed up or looking at the wrong functions. But I think for the most part, the second page looked pretty good. But the big issue was with that first page, that fractional power rule problem. Now, I just want to run through some of the mistakes that I saw, but I would say this probably doesn't apply to most of the students. It's just pockets of students that had a couple of issues with the cleanup. I think the biggest issue is trying to figure out what to do with that denominator. That denominator, a lot of students just want to find ways to avoid it or try to work around it, but we have to deal with that denominator before we can do power rule. So this example is not any of the versions, but it's very similar. So I just want to kind of run through that and then talk a little bit about some of the issues that I saw. But again, it didn't affect everyone. And second, if you made a mistake, I'm always looking to give partial credit. So it's not all or nothing. Okay. But a problem like this here. So the first thing is having to clean up that numerator, right? We've got to expand all the numerator terms out. And then once we're there, we have to split up into individual fractions because we're not ready for power rule. And then we got to subtract all those denominator variables up to the top, get them all ready for power rule. At this stage, then you can find the derivative using power rule. So as soon as you got to this point, I think they're pretty safe. Finding the derivative, that wasn't an issue. But getting to this point is the hardest part of the problem. One issue that I saw was, there's so much work involved with getting to the cleanup that some students just left this as their answer because all the work was, there's so much work that was done up this point. They didn't get to that derivative process and they just left their answer here. Some of the issues that I saw was adding terms when they were not like terms. So I saw some students do 3x squared plus 2x to the 1/3 equals 5x to the 7/3. If you're multiplying the variables, they can add exponents, but if they're not like terms, you kind of have to leave them separated. You can't merge them together. Another issue that I saw was getting up to this point here. Okay. And then looking at that 7, and some students would look at that and feel like that's a constant and start wiping them out. But this is not a constant. This is still attached to the variable here. So unless that 7 is by itself with nothing up below it, it's not a constant. So we can't cancel that out. So some students were canceling that out, and that threw off their answer. Third is this portion is not ready for power rule. And some students were just trying to avoid that denominator, so they started doing power rule from this point and stuff, making that power rule, and they just left that as the answer. So I know that looks easy, that feels easy, but that's not the correct process. So we can't do power rule when the variables are still stuck in their numerator and denominator form. Or another thing was students would separate into individual fractions, but then they'll do power rule here, and they'll do power rule 8 times for each of the numerator and denominator. So we can't do that either. And then another thing that I saw was some students would try to bring the denominator up to the numerator and make it minus 5x to the negative 5 halves. And when they did that, they just turned everything into power rule and completely avoid the denominator. So you've got to deal with that denominator in some form. We have to split them up into fractions. So I think that's the biggest issue. And then careful with your converting from radicals to rationals. Square root of x to the 7th is not x to the 1/7, even though it looks like it, or x to the 2/7, it's x to the 7/2. X to the 1/7 should look like this, 7th root of x. Okay. So as I'm grading, I'm also going to highlight, what mistakes that I saw in the hopes that you understand that mistake and you can clear it up for the test. So I should be able to have all your quizzes graded by Monday and give it back to you on Monday so you can look over it before your test. Our test is going to be on Wednesday. So a couple of help sessions, Monday morning, 7:30, Wednesday morning, 7:15. Tuesday morning, I have a meeting, so I'm not available Tuesday morning, but Tuesday afternoon, I can be available if you want to do a help session with me. So, but I think on Monday, we'll be able to go through. There's one more thing I haven't gone through, but it's just a very specific type of setup with power rule, and then we can put it all together with our test review.
So what the average was?
I don't know yet. Just I haven't graded. I've only finished grading like maybe half of it, but I would say probably like a high B so far.
Okay.
Yeah.
It's
not bad.
Go time.
And then zeros.
Yeah, and I
Then somebody.
that's the thing. Is it inner and from the beginning, like the one that's not like no.
Yeah. Is this the next one? I don't know, is that in the function? Wait.